Hello all, myself Rushank Parikh, 19 DCE 089 and my partner is Purav Patel, 19 DCE 109. Today we'll discuss the information security research paper on the topic cyber threat detection using machine learning. This is the index which we're going to discuss. So first is abstract. The modern world spends more time on the internet than it has ever done before. With each passing day, the use of cyberspace increases. As a result, the risk of cyber threats and cybercrimes are increasing. The word cyber threat refers to illegal internet activities. Organizations are increasingly seeking improved data mining approaches to evaluate security logs received from their IT infrastructures in order to provide effective and automated cyber threat detection in the face of the exponential rise in cyber threats. Thus, the analysis of security logs from the dataset is essential to ensure automatic and effective cyber threat detection. Conventional techniques are not capable of detecting zero-day attacks and sophisticated attacks. Countless machine learning algorithms have been created so far to detect cybercrime and combat cyber threats. In general, organizations are increasingly looking for improved data mining methods to evaluate security logs received from their IT infrastructure to provide efficient and automated cyber threat detection act in the face of an exponential increase in cyber threats. The goal for this research is to offer an assessment of some of the most extensively utilized machine learning algorithms for detecting some of the most dangerous cyber threats. Thus, the development of IDS, intrusion detection system, is essential to provide an extra level of security. However, due to vast number of negative threats detected, particularly in large-scale contexts, using machine learning algorithms for threat detection analysis has proven difficult. This fact brings a dire need for an efficient machine learning-based cyber threat detection model capable of minimizing the false detection rates. In this paper, we are proposing various kind of ML algorithms, ML techniques in spam detection and malware detection. Thus, the cyber threats and false detection rates are minimized using ML techniques, which improves the system's performance. These are the some keywords that is cyber threat, machine learning, network security, machine learning application, IDS, malware detection, spam classification, and SVM. So, introduction. Researchers have created techniques to detect threats because the attacks are carried out across networks that are classified as malicious behavior. As a result, an intrusion detection ID system IDS is employed to protect the network against such activities and attacks. The purpose of an IDS is to take data from a network and analyze it for the threat detection. There are a variety of approaches for effectively detecting invasions. With the growing number of cyber threats, cybersecurity has also developed a number of improvements in order to compare against cybercrime. Cybersecurity is a set of technologies, specialists, and processes that are used to provide safety measures to defend the cyberspace from cyber criminals. Basically, cyber threats include phishing, malware, attack on IoT devices, then denial of service attack, spam intrusion on network or mobile device, financial fraud, ransomware, and so on. Every day, billions of security events are generated by a typical company network with thousands of IT systems. Security information and management system typically only ingest a subset of the security events to run through threat correlation algorithms. But businesses are now striving to ingest as many security events as possible to meet regulatory obligations. However, in order to ensure efficient preparation of data before applying a well-trained machine learning predictor or classifier for future analytics, machine learning-based security analytics should be executed through an optimal workflow as illustrated in the below image. So this is the image of machine learning analytical workflow in which first it will train the data using various machine learning algorithms and its model. Then it will predict on the real-time data, and then either it will go in alert engine or decision engine. However, at the end, different algorithms work best for different security event types, and also analysts should choose one that better the model the data and lead to the least number of false positives. Now, literature survey. The authors detail the challenges that they have encountered when implementing ML techniques. Although ML Machine learning approaches are growing multiple ways to secure cyberspace against cyber criminals. The research indicated that a large number of breakthroughs are still required to protect classifieds from adversarial attacks. They provide a summary of numerous publications relating to the use of ML models to improve cybersecurity. They overcame some of the most common roadblocks to machine learning techniques, such as locating acceptable datasets with the best applicability for certain security challenges. Also presented a brief information comparison of different ML techniques, especially in anomaly detection. They gauged the performance efficiency of feature selection in ML for IDS. They claim that the CNN classifier is an underused classifier and it could have brought vast advancement in cybersecurity if it was used to its full potential. They also analyze the role of various ML techniques in spam detection, malware detection, and intrusion detection. They claim that there is no ML technique that is not vulnerable to cyber attacks. We have provided a detailed assessment of widely used ML techniques in this presentation in order to assess the performance of ML approaches in detecting some well-known cybercrimes. And lastly, the conclusion section will conclude the study. So intrusion detection system, that is IDS, it observes the activity in a system and chooses whether these activities are malicious or not. Network-based IDS analysis for all activities in network traffic and set up an alarm to whenever abnormal activity is observed. Malign intrusions over the computer network and devices are another cyber threat to cyberspace. Intrusions identify the weakness within a computer system for further attacks. An intrusion detection system is used to protect against these intrusions. There are three classifications of intrusions, namely signature or misuse-based, anomaly-based, and hybrid. Some of the common attacks against intrusion detection system can be used are denial of service, probing attack, user to root attack, and remote to local attack. So we'll discuss now machine learning algorithms. First is the data mining technique. Data mining algorithms have been recently used for development of intrusion detection models to reduce data overloading. These models extract useful knowledge by searching for patterns and relationships from the data collected, thereby improving decision making. In classification, the features of the new object are observed and are assigned to one of the existing set of classes. Classifier models gain knowledge from the training data and detect the class for the new instances. It is used for removing unwanted information over the network and keeps the important information in the network. Data mining is used in computer network for the security. Second is the anomaly detection. Has different patterns to searching information for expected behaviors. Number of techniques has been implemented to solve this problem in that one class support vector machine is a much useful method. SVM is the most useful technique of machine learning, and SVM plays effective role as a classification technique in a problem such as signal processing, often providing a huge enhancement over challenging methods. In cybersecurity, the SVM can decrease false detection rate and increase the accuracy of IDS. The classifier is useful to analyze the network traffic and differentiate two possible outcomes, malicious and non-malicious. It can measure the execution of IDS against different SVM methods, one class and two class SVMs. Attribute subset selection is an actual procedure of separate not pertinent data, increasing quality and refining result comprehensibility. Third is the clustering algorithms. The ability to analyze internet traffic is critical for early detection of cyber attacks and network security. Because of the high amount of internet usage in major organizations, statistical methods are unable to detect malicious actions. Arithmetical clustering can be used to distinguish between legitimate and malicious data because of the arithmetical character of the dataset and the fact that k-means outperforms other hierarchical approaches. It might access and compare clustering algorithms like k-means, db-scans means density-based spatial clustering, and BIDS, which means balanced iterative reducing and clustering using hierarchical for network traffic survey. So every machine learning technique is still struggling to keep a pace with continuously upgrading cybercrimes. Now, machine learning in spam detection. Spam is a security risk to computers and networks. It's a word for a message that you don't want to receive. Spam can come in a variety of forms. On mobile devices, it can take the shape of text messages, photos, and videos. Spam tweets and spam emails are the most commonly used mediums through computers and networks. Spam messages use up a lot of bandwidth and other network resources. Spam emails that contain irrelevant adwords take up a lot of time. Using the Andron dataset, however, DBN, which means Deep Belief Network, outperformed with a precision value of 98.39%. DBN also outperformed SVM, which is support vector machine, and DT, which means decision tree, in terms of recall and precision. On spam-based dataset, SVM performed better than DT with an accuracy of 96.90%. Using Andron dataset, the decision tree has shown better precision than SVM and similar precision to DBN. Now, machine learning in malware detection. Malware, shorts for malicious software, is a software that is installed on a computer to disrupt its information and harm the electronic data. Viruses, worms, ransomware, adware, spyware, malvertising, and Trojan horses are considered as significant types of malware. Malware interrupts the normal flow of computer operations. With a growing pace of usage of computing and mobile devices, the cybercriminal is finding it easy to compromise the integrity of data. Machine learning techniques are being used to detect malware. Static detection is a subdomain of malware detection in which applications are tested for malware without executing them. However, in dynamic detection, the applications or software are tested by executing them. Hybrid detection is a mixture of both static and dynamic detection. The decision tree has shown overall best accuracy of 99.90% on custom data collected by the author. However, on a malware dataset, SVM performed better than decision tree in terms of accuracy. SVM reported the best recall value of 100%. SVM is recommended based upon the cited papers to detect and classify applications from malware. So, conclusion. The conventional security techniques are not capable enough of coping with these threats. Machine learning techniques are being applied to overcome the limitations of conventional security systems. Machine learning techniques are playing their role at both the ends, at defender end and at attacker end. We have presented multiple examples for using ML analytics to enhance cybersecurity monitoring for common cyber threat cases. ML-based analytics is an excellent tool to provide context derived from learning security events, normal behavioral baselines, and leading to minimal number of false positives, security alerts. In addition, ML analytics are best suited to analyze huge volume of security events and feed deviations from normal baselines into proactive threat hunting processes as indicators or leads to potential malicious activity. Moreover, supervised algorithms will have limited role to play in the future because of operational cost of preparing good and bad training data to train algorithms model. Semi-supervised algorithms like one-class SVM are relatively easier to train, more cost-effective and better suited to enable SOC analysts to perform novelty detection and uncover new indicators of compromise. Thus, we have discussed and concluded that we cannot recommend a particular machine learning technique for every cyber threat detection. Different learning models are being used for specific different cyber threats. On the other hand, there is a vast number of authors who have worked to highlight the constraints faced by machine learning techniques. These are some references, and from 3 to 8, these are the drive links of studied research papers. So, thank you.